Okay, I think we're live.
So any questions so far? Ones you'd like to see done or talked about before I jump into this Riemann sum worksheet? So remember where we are so far. So we're talking about Riemann sums. And what we mean by a Riemann sum is any strategy we use, any way we can organize an approximation to an area under a curve using rectangles. So if we have some curve, whatever it may be, and we want to approximate that area under the curve, then we can do that with a finite number of rectangles. And so we can make those rectangles whose right side is on the curve, in which case if we did that all the way through, we would call it a right Riemann sum. If we made all of our rectangles have the left side on the curve, we call that a left rectangle, and all of those would be a left Riemann sum. We could take the midpoint and put that into the function and use that as the height, or whatever means we want, okay? So we have talked about that any kind of Riemann sum is gonna look like a value of the function on some subinterval. So the interval goes from A to B, we divide it into n rectangles. I think it's easier to wrap your mind around when you imagine those rectangles being uniform width, but they don't have to be. If they're uniform width, then that delta x is going to be b minus a over n. So the b minus a is that interval length divided into n subintervals of equal length. Then each of these is referred to as a subinterval. It's that delta x, it's that width of the rectangle. And so we can devise different strategies for plugging in some value of x on that subinterval into the function to make its height. So whatever we choose for that x of 1 in the first rectangle, whether it's the left side, right side, midpoint, or something else, then we're going to multiply it by delta x. That becomes the area of that first rectangle. So that's the area of, that represents this area right here. And then we do that again, and whatever our scheme is for getting the height of that rectangle, we plug that value of x into the function to get the height times delta x, and we do that until we have n of those rectangles. And so that can be written in a more compact form using what we call summation notation. So we write this Greek letter sigma, and we call it the sum, or the summation, I going from 1 to n, of x sub I times delta x. And so that's going to give us an approximation to the area under the curve. Now, what we have said is then, if we take that limit as n goes to infinity, we take an infinite number of rectangles of uniform width, then it no longer is an approximation, but we get true equality to that area under the curve. Now, there are some times where we can tell, based on whether the function is going to be increasing or decreasing, and whether our Riemann sum uses left rectangles or right rectangles, whether it's going to be an overestimate or an underestimate. So for example, if we have a curve, and that curve is decreasing, and if we are going to approximate this area from A to B and we use left rectangles, I would just draw a picture of it, but you can see, are those rectangles going to give us a finite number of rectangles, is that gonna give us an overestimate or underestimate? Yeah, and if the reason is, so if the function is decreasing, then left rectangles will result in an overestimate. You'll be expected to know this on the AP exam. That's a regularly appearing question. Now, if we were on this, if we had a decreasing function and we used, I'm gonna make them look different here, right rectangles, so look at the purple one there. If we look at those right rectangles, will they be an overestimate or an underestimate? So right will be an under. Now, it'll be exactly reversed if our function is increasing. So it doesn't have to do with concavity, it has to do with increasing or decreasing. So if we use left rectangles here, you can see that because the function is increasing, our left rectangles are gonna leave gaps there that we're not gonna be able to account for. So if f is increasing, then I'm going to call it a left Riemann sum, LRS, is going to be an underestimate. And again, I wouldn't memorize this. I would just, when asked a question, I would just draw a picture and look at it. And draw a few rectangles and you'll be able to tell. So if f is increasing, and what I use purple, so a right Riemann sum. So if we use rectangles that are going to use the right side of the subinterval as the height, and you can see you've got all these overlaps, and so that will then be an overestimate. Does that make sense? So it's no big deal now, but in not too long, we're going to approximate area under the curve, not using rectangles, but using trapezoids. And when we do trapezoids, it will turn out it's not the increasing and decreasing that matters, but it's the concavity. Is it concave up or concave down? So you're going to have to kind of keep that straight. So I'm putting that out there now so that, when you draw the picture to remind yourself, is this going to be an overestimate or underestimate? It doesn't matter what the concavity is for rectangles. It does matter whether the function is increasing and decreasing. When you do trapezoids, the increasing, decreasing doesn't matter, the concavity does. And so, and don't try to shotgun it, because what happens a lot of times, because those questions will come up, one of the two or maybe both, and people will not be sure, so they'll say, well, it is an overestimate because the function is increasing and concave up, and then you've lost the point because you have to distinguish which of those. It's not concavity or rectangle, it is the increasing and decreasing. Okay, so what you will be expected to do on an AP exam question is to do a left Riemann sum, a right Riemann sum, and a midpoint Riemann sum. So they don't generally ask you random point ones. So, and typically when they give you these, you'll see it given in a table of values. But what I want to do here today is, we have this worksheet. So this is on Canvas. If people are watching virtually, you can pull this out. And I want to do this with you because part of what this worksheet will help us do, I hope, is get a feel for what do we mean by a left Riemann sum, a right Riemann sum, a midpoint Riemann sum, a uniform width versus a random width rectangle, a random height versus, left, right, or midpoint, and get some of those, some practice with those. So we're going to go through here and we're going to mark this all up and draw our rectangles. We're going to use our calculator to help us with all the arithmetic. And so it's easy to, when you're doing this, get all wrapped up in the calculator aspect of it. That is not the part that's important. And in general, when this kind of question appears on an AP exam, it's not gonna be so many rectangles that a calculator is gonna make a difference. And probably it'll appear in the non-calculator section. You know, typically what you'll see on an AP type of question is you'll be given some kind of table of values, you know, where you have f and f of x, and maybe, you know, you got 1 and 3, so the spacing between these is 2, so they'll probably make the spacing here something different, you know, so it's not really formulaic, and then they'll give you whatever they give you, you know, maybe the values here, and then 5, and then 11, something like that. And then they'll ask you to do a left Riemann sum or a right Riemann sum or a midpoint Riemann sum. We need them to be evenly spaced, but we'll see examples like that eventually. But it's not going to be something where a calculator is going to make a difference. You know, it is not one of the calculator skills that you need on the AP exam to be able to use that stat function where you make the lists and put them in there like we're going to do here. That is not, if you're doing that on an AP question, you didn't understand the question, because it's not something that's on their syllabus. The 4 things you have to be able to do on a graphing calculator for an AP exam are going to be to graph a function, to find a zero or an intersection of 2 curves, either find where does the curve cross the x-axis, or where do 2 curves intersect. Can you do the numerical derivative part of that, and can you do the numerical integration that we talked about last time? Those are the 4 things you have to be able to do on a calculator, and you will have to do all of those things on there. But not what I'm gonna do here in terms of using the stat function, but it'll make our life easier here. So let's turn our attention to this. So you can look here, and so part of it is notation. So I'm just notating on the worksheet here. He's gonna use capital L sub n. So when he says L sub n, that means it's gonna be a left-hand Riemann sum, and the n is telling us how many rectangles we're gonna use. So L3 would mean it was gonna be a left Riemann sum with 3 rectangles. When we see the R, that's gonna be a right Riemann sum. So an R5 would be a Riemann sum using 5 rectangles, and we're gonna use the right side of the rectangle to get the height. And then likewise, they'll do an M sub n, and that's gonna be a midpoint Riemann sum. So what I wanna try to do here today, I'm just gonna lead you through a little bit. If you look at the front page, we'll do that. We're gonna do left Riemann sums with 6 rectangles with the function that they're giving us. F of x equals 9 minus x squared on the interval from 0 to 3. Then we're gonna come on the other side and we'll do a right Riemann sum. We're starting out with uniform width rectangles. Then we're gonna do a midpoint Riemann sum. Then we're going to, in the part B section, in the middle of the actual worksheet there, then we're going to do a random height, but still uniform width Riemann sum. So we'll still keep all the delta x's equal to each other. They're all gonna be 0.5 or 1/2. But we'll pick random points on there. We'll do that together so that we can agree on what those random heights are. Otherwise, if you're doing it, you're gonna pick something different than somebody else. You can't really compare your answers and see if you're doing it right, because it won't be the same answer anyway, even if you're both doing it right. And then the last one's the trickiest, but more involved. We're gonna do random width and random height, and hopefully we'll get to there and do that. And if we can get, the hope is we'll get through all of that, and we're gonna spend a couple days on it. We'll do today and tomorrow. Then the next part, that number 2, they give you a different function. So now, hopefully after we've been through the first one, then you're gonna get a different function, and then instead of doing Riemann sums with 6 rectangles, you're gonna do with 8 rectangles. So it's similar, but not exactly the same as what we did. Again, using your calculator. And then you go through and do all of those. You do a left Riemann sum, a right Riemann sum, a midpoint Riemann sum, a uniform width random height Riemann sum, and then finally a random width random height Riemann sum, which is the most obscure, and come up with an answer. And then there's some questions at the end, and hopefully we'll get to those where you're gonna use your graphing calculator and do the numerical integration. And if we don't get to those today, we can talk about it tomorrow. You get a shot at it. Okay? So let's look at that first one. So we got this 9 minus x squared is our function. And you've got a graph of that on your paper there. Now the scaling is not the same on the x and y because this is 9 all the way up here and this is 3 here. Now you see a bunch of vertical dots on there where we're gonna split this into 6 rectangles of uniform width. Since our interval is going from, let me write down, f of x equals 9 minus x squared, and our interval is from 0 to 3. So since we're going from 0 to 3, and we're making 6 rectangles of equal width, then each of those is going to have, a width of how much? Pauses for you to respond there.
Fine.
Yeah, they're all gonna have a width of 0.5 or 1/2. Does that make sense? Okay, that's our b minus a over, our b minus a over n in general is how we get the delta x, or the width of a uniform width rectangle. And we have 3 minus 0, and we are making it into 6 rectangles. And that's another way to kind of get a formula for that delta x. So let's draw now 6 left-hand rectangles here. So make sure that we're seeing this and understanding it. So on that first subinterval, we're going to use the left-hand side of the subinterval, that 0, is going to go into our function, and that's going to be the height of that first rectangle. Is that okay? And the next rectangle, we're going between 1/2 and 1. We're going to use the height on the left side to be that second rectangle. And continue this until you can draw those 6 rectangles. 1, 2, 3, 4, 5, and 6. Okay? Now, so this is what the person I stole this worksheet from would call L6. We have 6 rectangles using the left-hand side. And so that is going to be, f of 0 times our delta x, which is 0.5. And then we would get f of 0.5 times our delta x, which is 0.5. You with me here? And the next one would be f of, up to the third rectangle would be f of 1. And again, the delta x is going to be 0.5. And the 1, 2, 3, 4th rectangle is going to be f of 1.5, and then again the delta x of 0.5. And so we got 1, 2, 3, 4. The 5th rectangle is going to be f of 2 times 0.5, and our 6th and final rectangle is going to be f of 2.5. And so with a left-hand Riemann sum, we're not going to use that right endpoint. We're not going to use the 3. For right Riemann sum, we will. Okay. You can see the arithmetic here is going to be really a little bit daunting, because what we mean is all those values are going to go into our function here. So what we're going to do now is use our calculator to do all the arithmetic stuff. So we're going to, in our L1, so let's grab your calculator. Gain all this other technology, but I lose the technology that I have. So this won't hook up. So we're gonna have to talk our way through it here. So on your calculator, if you go hit the stat button, that's the second row, third button over, and then hit enter, you're gonna get some stuff in there. Now, I don't know what yours looks like. I got a bunch of junk in L1 and L2. Does anybody not see L1 and L2 and L3 there? If not, we gotta renumber them. Okay, then what I'm gonna do, I have stuff in L1 and L2, so I'm gonna go, in L2 I'm gonna go up arrow, so now I'm up where it says L2, that's called the formula bar, and I'm gonna go clear, enter, and that's gonna wipe the slate clean. Is that okay? And then I'm gonna left arrow, so now I'm under L1, and up arrow, now I'm in the formula bar there, and I'm gonna hit clear and enter. So now when I look at my screen, everything's blank. I can still see the L1 and the L2, but there's no numbers put in there. Is anybody not at that point? Okay, not, okay. Okay, I think we wanted Now, what we're gonna put in L1 are gonna be always, that's gonna vary now as we do a left Riemann sum, right Riemann sum, midpoint Riemann sum, and so on. We're gonna put in the x values that we're going to plug into the function. So we're gonna put in 0, 0.5, 1, 1.5, 2, and 2.5. 1, 2, 3, 4, 5, 6. Okay, so let's do that together. And so we got 0, enter, 0.5, enter, 1, enter, 0.5, enter, 2, enter, 2.5, enter. Okay? Now then in L2, we're going to, let me make sure I'm following it the way they're telling us to. Yeah, so then what we're gonna do is we're gonna plug in all of these values in L1 into our function, and those are gonna give us our heights. And those are gonna be the values of f of x. And this is where, again, the power of the calculator. So I'm gonna go right arrow, so I'm in L2. I'm gonna go up arrow into the formula bar. Okay, you with me? Now, we want 9 minus x squared, but what I'm gonna plug in there, I'm gonna go 9 minus L1 squared. And so then when I do that and hit enter, it will fill all this in by plugging each of those numbers into that function and doing it. So I'm up arrow, so I'm gonna go 9 minus, and L1 I think is second 1. That's showing up as L1, and then you can hit your x squared button. So 9 minus L1 squared. Now hit enter, and magically it all fills it in. Kind of slick. So you're seeing then, so you're getting like 9, and then 8.75, and 8, and so on. Okay. Then we're gonna, so I'm just gonna write, so we have 9, 8.75, and those are all filled in. Now, over in L3, we're gonna put in our delta x's. Now, for right now, we're gonna go uniform width. So all these have the same delta x as 0.5, but eventually down the road here, when we do the random width ones, we're gonna be making these up and we're gonna change them. But for now, we're just gonna enter 0.5 all the way down, and I don't have a good, I don't know if there's a good way to do that, but I'm just gonna have to go 0.5, enter, and do that 6 times. Okay? So now what we have, and we're going to right arrow over to L4 here. So in L2 we have all the heights of our rectangles. Those are the f of x sub i's. And in L3 we have all of their widths, okay, of our rectangles. So we want to multiply those together and put those in here. So again, we're going to go up arrow into the formula bar. And so we're going to take L2 times L3. So if you go second 2 button times second 3 button, you should see down below there L2 times L3. When you hit enter, it fills all those in and it multiplies each of those in there. It may not getting to there. So my first one looks like 4.5 and then 4.375, and there's something filled in there all the way down. Do we not have that? So now here are the areas of our 6 rectangles. Now we want to add all those up.
Wait, could you go back to like the, I don't understand how you got the L4, the formula part.
So you up arrow into there, and we're gonna put in L2 times L3. And that's second 2 button times second 3 button. Okay, that look the same?
Yeah.
Okay, anybody else? We good to go? So what we want to do now, these are the 6 rectangles. They're individual areas here. We want to add all those up. So for this, I'm going to get out of the menu that I'm in now. So I'm going to go to the home screen. So I'm going to go second mode, and that's going to take me just to the home screen. Now, what we can do is sum up all of these, and I got to remember how I do this too. So I think I want to go stat again from the home screen though. Right arrow to, no, not there, not there. How about second stat? Gotta find it. there it is, second stat, and then arrow twice over to the math menu in there. And you see option number 5 is sum. Anybody not with me? Now arrow down to there, hit enter, and you'll see a sum parentheses. And we want to sum everything in L4, so now we'll go L4, which is second 4, close the parentheses, and then hit enter, and I'm getting 20.125. Is that okay? Okay. All right. So, I don't know how much we can do on our own. Do you think you can do the right Riemann sum on your own? So what would we have to change for a right Riemann sum? So we want this to go, instead of using, we're not gonna use 0 at all. We're gonna go 0.51, 1.5, blah, 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 all the way down. We're gonna get 3 in there instead. Crazily enough, it doesn't matter the order you do it in. So you can just overtype 3 right here. That'll replace the 0 by 3. Now, anytime you change something, you have to redo your formula bars. So when you change the 0 to a 3, you won't change this column. You're gonna still, after you change this, you'll right arrow, up arrow, and you'll have to go back in 9 minus L1 squared. That makes sense? And likewise, here, you're gonna have to come up and back up and go to the formula bar and go L2 times L3. And then you can sum that up. Okay? Now, hold on, you can do that on your own. Hold on. Oh, you go ahead and do it. It won't take you but a minute, I hope. I have my answer up here, you can check whenever you get a chance. Are we agreeing? If not, let me know, we'll try to fix that. Pearson, you with me? Okay. Emily, still working on it? Do you need another minute? Zane, you okay with it? Zach, did you get the same thing? Okay, let's do a midpoint Riemann sum. Now, what do we have to change here? Yeah, the first one's here, because now what we want to do is we're going to plug in for our height, we're going to plug in the midpoint of each of these sub-intervals. And that is how we're going to determine the height of each of those rectangles. So it's not the left side, nor is it the right side. So all these are going to be changed. So what is the very first one we're going to plug in going to be? We're halfway between 0 and 0.5, so it's going to be a 0.25. What is the next one going to be?
So 0.7.
Good, because you still have a uniform width of 0.5, so if you add 0.5 to the 0.25, that's going to be the second one. Does that make sense? And the next one will be?
1.25.
Okay, go ahead. Now, after you get all those down, is the L3 going to change? What's our width going to be?
1. No, 0.5.
Still 0.5, so there's still 0.5. So you're going to still have to retype in the formula bar for L2 and L4, but you're not going to have to change L3. So So you should end up with your last value in L1 as 2.75. I got an answer up here. Hopefully we're agreeing on that. Is that okay? So let's do this. I'm trying to think. We're not going to have time to get through the random width or the uniform width random height. What we would do, what we're going to do, you can try them on your own if you like. And we're going to work on some of these tomorrow. I'll go through it again. There's also a video on the support videos where I have gone through this whole worksheet that you're welcome to do too. So what we would do is we keep these as being 0.5, but we would just make up values for each of these. So we would make up anything between 0 and 0.5 and plug that in. Make up anything between 0.5 and 1 here. Okay? And then after that, we're okay. On the random width, what we're going to have to do is first go through and decide where are we going to put the delta x's, what are the signs going to be. So between 0 and 3, we're going to have to decide, you know, what are 1, 2, 3, 4, we need 5 markings, I believe. 1, 2, 3, 4, 5, 6, yeah. So you're going to have to pick 5 of these values here that you're going to first decide as the boundaries of your delta, of your rectangle. Then you can figure out what are each of these delta x's. So they're going to be different, and they're going to have to go into your L3 as those delta x's. Then you're going to have to decide where the random height part is going to be. What are you going to plug in for your value there? But write them down, because otherwise you never have. There's no way to tell if you got it right or not. Better yet is to do it with a friend, and you say, okay, let's do this for these choices, and then you can pick, you know, whatever these values are, they're going to go into L1, and then you can get your sum. But you won't be able to compare with anybody else because they're going to do differently. If you want, you can do it with my video, because then you'll at least have the same values so you can see if you get the same result. So that might not be bad. And then tomorrow we're going to work, and then we'll try to finish the worksheet. It's going to be part of the assignment in the next 2 days, so today and tomorrow. Very good.